wish you could have end-to-end observability from applications to infrastructure? With Amazon CloudWatch APM, you can monitor and troubleshoot applications, services, and dependencies. Your data all in a single console. Now that's observability.
Hey folks, this is episode 12. Welcome to the AWS Cloud Operations Show. This is your host. My name is Emil Kumar Jagannathan. I'm really delighted to welcome you all to the show. Today, well, as you know, I'm streaming live from Atlanta, Georgia, and it's 2 p.m. on the East Coast in the US. It's summertime and it's really hot. And we are also going to have a really hot conversation. Cloud operations. What else, right? All right. So this show is pretty unique, and we have not done this kind of episode before. We are going to have a customer join us today to talk about their experiences and the best practice that they follow in managing their large-scale, super busy environment. Right. To facilitate this conversation, we also have two of my amazing colleagues who are going to join us. Now let's go meet them. Hey, folks, welcome to the show, and let's get the introductions going. Ian, do you want to go with? Do you want to start this?
Yeah, thanks, Maya. Yeah, my name's Ian Board. I'm a staff engineer at JustEatTakeaway.com, and I've been working in reliability engineering, so involving operational response and observability at Just Eat for the last 10 years. And yeah, we've got some of our best practices to share with you today through the session.
Fantastic, Paul.
Yep, I'm Paul Moran. I'm based in Edinburgh, in Scotland. I've been working in the enterprise support business within AWS for the past 10 years. I contribute towards the cloud adoption framework, the operational excellence pillar, and I'm a co-creator of the sustainability pillar for Well Architected. And my interest here is about that operational excellence and raising the bar in terms of operational resilience. So good to meet everyone.
Excellent. Nisha?
Hi, everyone. I'm Nisha. I'm a technical account manager in enterprise support, just like Paul. And I've been here nearly 6 years now. It'll be 6 years in September. I'm based in London, in the UK. And primarily in my job, I work with our enterprise support customers, making sure their AWS architecture is resilient, secure, and it's following operational best practices.
Fantastic. Once again, thank you all for being here. This is really amazing. Specifically, Ian, thank you for being AWS customer, and also thank you for taking your time away and willing to share the experiences. And this is really inspiring and exciting because we talk about best practices, we talk about new technologies, talk about upcoming stuff all the time, and different avenues and different episodes, even on this show. But it is really important to learn from a customer, because every situation is different, every environment is different, everybody has their priorities set differently, and it is good for everybody to learn from how different customers are making use of observability or deploying observability to maintain their environment and applications better. Thank you so much. All right, I'll start with Nisha. Nisha, you are a TAM, Technical Account Manager. You work very closely with customers, and you have seen, I guess the last thing that you always want to hear is the buzzer going off, like that there's something happening somewhere and then you need to address, right? That's the last thing you want. But going through that experience, you have come across different use cases, different scenarios, different reasons why things break. Can you walk us through on those different scenarios where things could go wrong and how customers could sense that?
Yeah, sure. So yeah, as you said, as a TAM, I get called into some incident bridges when the customers have production pain, and my job at that time is to kind of make sure like they are looking at the right things which could cause the issue. So when I say a cause here, I'm actually referring to that one action the customer should take and which has triggered the problem basically. And it's not the root cause per se, but it's the cause which will help them get out of the production pain and get the business back up and running. And working through different customers, I think the 5 causes can be that totally like this incident can be into 5 different causes, which could be like the first one is they change something. So like a change was made in a code, or our infrastructure would change, or some config change, maybe a database schema change, which hasn't gone well. And maybe it was tested in non-prod, but not at the scale as it was expected in prod. And that does not perform well in production when deployed. So the immediate action that customers should take at that point would be just roll back the change, right? The second cause that I often see with customers is like the inputs have changed. So maybe there's a sudden spike of requests coming through to the system, and it's not able to scale. So, or other way would be there is no spike in the request, but the way the requests are being handled has changed again. So, like going back to the change, right? In that case, they just need to add more capacity to make sure it can handle the spike in the request come through. The third cause I've seen is like they bumped into some limit. Again, like they ran out of CPU, so they need to scale up again on there. Or another kind of issue I've seen, like where certificate is expired, so they need to renew the certificate. And this immediate action will help them come out of the pain.
And also, I mean, not necessarily this has to be either or. It can be a combination of these things as well, right? It can be multiple factors, yeah.
Correct. Yeah, that's right. Because like you said, it could be like maybe they changed some credentials, which did not go well again. So it could be like related to change. Said. The next one, which is again very common, is a component failure. When a component could be like a physically or logically separate system, which can fail separately. So suppose you have a part of system that's working well, but there's only subsection which is not performing. It could be like a faulty EC2 instance or an EKS pod or an availability zone, for example. Once you identify that, you just kind of remove that bad component or replace it with a good one to make sure everything is up and running as expected. And finally, there's one which is, again, the most trickiest to identify is the dependency failure, that your system is working fine, but something that you actually depend on is not functioning as expected. Or the other tricky part is like dependency is fine as well, but the way you are calling the dependency has changed. So these are the kind of 5 categories which I often see incidents happening.
Yeah, and also the interesting factor here is that there are some that are controllable factors and some are not, right? So we change something, for example, is a 100% controllable factor on one end of the spectrum, and then all the way on the other end of the spectrum is something you depend on fails. It could be a third-party SaaS product that your application makes a call of, and maybe they have some limits or they have some outage going on, and then because of which there's a cascading effect on your products, your services, right? That's the most complex part, I guess. I guess the way to design that is to handle it at the application layer or somewhere to kind of have a failover mechanism. Maybe you can queue the requests and then process that later and batch this later and so on. There are multiple techniques that people can use. All right, sorry, keep going.
Sorry, no, I was saying, like, Amaya, when you said it's sometimes a combination, so the input's changing, so a sudden influx of traffic and hitting some limit, those two can come hand in hand sometimes as well. So, be it if you can forecast that in any way, or give yourself more headroom in terms of your max size you're going to, you can help avoid that. Obviously, there could be a cost implication as well, but it's important that, like you say, although these things can happen in isolation, often you might have an unfortunate combination. Sorry, Nisha, carry on.
No, that's correct.
Good point,
yeah. And I think widely when we see these 5 causes, we recommend customers, you can almost use it as a checklist. And when you use as a checklist, like, okay, the team can then operate in parallel and then troubleshoot at the same time and then communicate with each other to say, okay, you look at what has changed, I'll look at the component side, and then it will help speed up the investigation as well. And add that when your production system is down, speed really matters. So distributing within the team and making sure they're communicating with each other will help them get unstuck from troubleshooting. And having this as a checklist also make sure that they're focused and they're not diverted into different things at the same time. So maybe, Ian, can you share how do you do it in justeattakeaway.com?
Right. Yeah, that would be, I'm curious now. Like now when we talk about the problems, now I want to see how Just Eat solves it. Just by looking at the logo, Ian, I'm getting hungry already. I think I should order something to, something to eat. Oh, I'm also hungry for knowledge now, so that's there as well.
We definitely, hopefully, I can help out with that. So, yeah, I work at JustEatTakeaway.com. So, we're a leading global on-demand delivery company. We operate in 17 countries around the world, including Canada, Australia, and Europe. So we have sort of a global presence, and we work through numerous time zones. In 2024, we work with over 350,000 partners, and over 60 million customers used our platform in order to fulfill well over 500 million orders. And that's all done by hundreds of microservices deployed into AWS and integrating with AWS and other third parties. And so, as you can imagine, we've had to solve observability and operational response challenges at scale to make sure our customers and restaurant partners have a smooth experience. So yeah, hopefully I can talk to you now a bit about how we do some of that. We start with the idea that observability is non-negotiable. And actually this is one of our observability guidelines, observability by default. And that gives a high level of what we expect people to achieve when they're building their applications, their components. And we want them to have it in mind from the ground up so that they make sure they're keeping in mind we want to measure elements of their code that are important and aspects of behavior. So we want logging metrics and distributed tracing and an operational dashboard.
Can I just ask a question around that in terms of its importance? You just said you operate in 17 different countries and territories. How central is the choice to make observability by default to the success of being able to operate across those territories?
So yeah, to do it smoothly, it's pretty critical. So if I explain the operating model slightly, so the teams that build and maintain our applications are operationally responsible for them. And they can be based anywhere in the world. And we also have a 24/7 platform operations team, and they're located around the world so we can do a follow the sun model. So by having this consistency in our observability, we make sure that whilst the component owners themselves can investigate any issues with their components, we also make it more portable so that our platform operations team are also able to do the same. And that can be really vital when you're looking at issues that could potentially be impacting customers, and it could be impacting them in one market or several. So it's important, like super critical, that we have observability in a consistent and approachable way so that we can get the business value of that. So yeah, we don't want issues to go unnoticed, and we don't want people to struggle to be able to reason about people's applications and infrastructure.
Got it. And also looking at this, obviously you probably have a lot of interactions with third-party solutions, third-party APIs, right? Like the vendors and restaurants and all the different ones and maps and so on. And I'm looking forward to learning how you're, making sure how you're handling that, right? Like in terms of operations point of view. So that I'm curious about that.
Yeah, so from that standpoint, so we want to make sure like we have that visibility of third parties, and a little bit later we'll talk around how we structure some of our, so we recommend a structure for our dashboarding, and those recommendations come from what we call a launch coordination process. So we have a mandatory stage before teams deploy into production where there's a peer review of their observability and operational readiness. So it's not to do with architecture, it's more around how well standards are being adopted at the point of going live or after significant operational change. For example, we did a migration from EC2 to EKS. And so that required us to go back through this process with a number of our engineering teams to make sure that we had, the observability we had in place had been updated for the new kind of workloads. Kind of in line with that. Oh, sorry.
Yeah, that is. And I just want to go back to, maybe Nisha a little bit. Nisha, I know you mentioned about different problems, different root cause situations that can actually cause issues. Do you want to talk about like different layers in which you can collect signals and so on, right?
Yeah.
I think that'll be important for us to understand where the issues are actually originating from.
Sure. And I just wanted to touch on the launch coordination process as well, which Ian mentioned. I think we follow similar within AWS, and our well-architected documents also recommend like an operation readiness review to make sure the observability is in place before anything goes into production. So the teams are ready should there be any problem. And to get the right observability, there are basically two types of relationship which we notice. Like one is the infrastructure plane, which is the actual infrastructure that's running in the cloud, and you have like the load balancer, target groups, and instances. And CloudWatch can join those dots automatically by using the Describe API, right? But the next key one is to kind of connect this infrastructure plane with the application plane and form that bridge. So this won't happen automatically. Like we suggest customers actually implement some application signals, application metrics in there to join that application plane to the infrastructure plane. And this can be done in two different ways. Like if you're using OpenTelemetry, which is like the open source framework for observability, you can use labels, and by attaching the labels, the application for each application or microservice here, it would say like, okay, this is the EC2 instance, which is the hardware I'm running on, and that's how you connect the infrastructure plane with the application plane. And that once that bridge is made, it's pretty easy to kind of connect those dots. And okay, you have the application metrics now, which is showing you what infrastructure is under that application, right? But then the key part is once you travel from an infrastructure plane to the application plane, you need to understand what are the dependencies between the different applications. So like in here, what are the microservices this application is talking to? So for example, if I have 4 different applications here, I need to understand if there's an issue in application 4 and which is affecting application 1, I need to know how what is dependent here, and need to know ASAP as well. You don't want to be finding that relationship while you actually live incident. To create that application to application mapping, like microservice to microservice, you can use distributed tracing, which is the trace ID becomes like a pattern in a relay race, which is being passed from as soon as the application enters the system till its end, the trace ID follows the request. And then this trace ID you can map in a common central place like Amazon CloudWatch, where the spans are collected, and you have a nice topology created so you can see how the service map looks like. The other way, if you're following OpenTelemetry, is to kind of use semantic conventions, which each microservice is emitting some golden signals, like on its own performance, and also the performance of its dependencies where it's talking to. So on left, you see like service metrics, and I'm taking a metric called latency. So application 1 will emit what is its own latency. And in client metric, it will also tell us how is the application 2 performing as in respect to application 1. So it's going to give you feedback on both ways. Once you have this like mapping set up, it's easy to create the topology. So you have like application 1 talking to app 2 and app 3 as an outbound service, and they in turn are talking to app 4. So this is how you can create a nice topology. And once there's an incident happening and you're looking at the right place when there is an application 1 showing a dependency issue, you can quickly go look at the service map and then see, okay, it's actually app 4 which is having a problem, and then work backwards from there. And then again, going back to those 5 causes, making sure like, okay, what was changed, or is this hitting some limit or something like that.
Right. And this also directly correlates to what Ian mentioned earlier on observability by default, right? Like only if you have that kind of approach or planning, you can actually get here, because this requires what you're just showing on the screen requires being intentional about adding labels to the metrics and being very particular about what they mean and how they'll be consumed at the end. Right? Unless you know what you're going to do with the data that you're collecting, you're not going to be able to understand what you need to do at all to begin with.
And in CloudWatch, it's pretty seamless because CloudWatch can see some custom metrics coming from application, and it can relate that, okay, this is the EC2 instance where the custom metrics is coming from. And in application signals, it shows you those custom metrics. So it lifts the overhead of you for implementing the labels, basically. So it's pretty seamless when it comes to CloudWatch.
Awesome. I'm interested in seeing how Just Eat Takeaway.com actually does it through Ian. Before I get there, I want to quickly call out people who are watching. Thank you for watching. Please hang on and also ask questions if you have. If you have questions, like, you can directly post a comment on the live stream, and if they're relevant for the conversation that we are currently having, I'll post that on to the panel, and then we can discuss about it. So don't hesitate. If you have questions, just keep them coming. All right. Having said that, I want to go to Ian, and we can see how JustEatTakeaway.com does these things here.
Yeah. So I mean, it's Nisha mentioning OpenTelemetry and distributed tracing. So one of our guidelines is that we try and use open standards and open source so we can. And OpenTelemetry is one of those really nice things that it helps you to get great observability, but also enables you to do it in a way that's flexible and avoids engineers having to keep recoding. So it kind of decouples it nicely from the observability backends. But obviously, it's all great having the instrumentation and collecting the metrics, but we want to really be able to do something with that data. So when we get signals, we want to be able to reason about the behavior within our system. So I did mention earlier on, as part of our recommendations for how people structure themselves operationally, we like to try and make sure that there's some way of relating different changes in metrics to one another. So I'm hoping that everyone here can see that this is the dashboard for my e-commerce platform. And I know every single one of these metrics looks fine. So over the next few minutes, I want to talk about the recommendations we make and how you can use common tools, common features of pretty much any dashboarding tool to give meaning to these panels really quickly and hopefully help to get to the bottom of root causes faster.
So would you say, Ian, the focus is on, like, in the industry terms, like red metrics, like errors and, this kind of response, which is latency and so on?
Yeah.
Or so this goes a little bit beyond that.
So this goes a bit beyond that. So we do. So those application level metrics are really important, and that they can help to sort of create SLIs and SLOs. But what I'm trying to show here is things that, for example, a KPI and errors by component and latency by availability zone. So this would be an example of a platform level dashboard, something looking at the bigger picture, so the higher up than just looking at an individual component. And the KPI, like I say, looks fine to me. By using baselines, we can validate that things look how they expect it to. So knowing what good looks like is really important. And hopefully straight away, even though we don't know what that KPI is actually measuring, we can still see that it's tracking with the baseline, and we haven't got anything to be too concerned about. The other two panels are measuring errors, application errors omitted by component, grouped by component. And then we've got latency by AZ, grouped by availability zone. These probably make less sense to have that sort of baseline. They could be quite variable. But what most dashboarding tools let you do is visualize your alerting thresholds. And that gives context to the metric. In terms of our warning and alert thresholds, where's it sat now? So the middle one, component errors, that looks fine. It's well below the warning threshold. We don't want to worry about that too much. Latency, AZ, looks like it's sort of sat on the warn. And this is one of the things you do want to be careful of, is when you're setting thresholds for things, make sure you review them regularly, because you don't want to get used to things being on the borderline of alerting thresholds, because you don't want flapping alerts. You don't want people to get bored of hearing the same thing and assuming it's always the same issue.
And I have a question on this. Like, I know you have this this section called latency by AZ, and I'm guessing you operate like across different regions, AWS regions?
Yeah, we have. So, like I say, yeah, the operation is global, right. So we do operate across different regions. So these sorts of things can be really critical. We for our purposes of resilience, we mandate operating at least across 2 availability zones for our lower tier features and 3 for our critical tier. And obviously that's for reasons of redundancy.
Got it. When it comes to dashboarding, so I know is this region specific, or do you have a view where you have like one place where you can see everything?
So because our platforms are isolated by region, we would normally have some sort of selector on the dashboard. So you know which so you change it for which market you're interested in, and all of the variables on the dashboard will update automatically, so that you'd immediately get the correct view. So yeah, so there would be some element of making sure you're looking at the right market, but once you do that, everything else should automatically update, so you're getting data from the correct place. What I want to show you just quickly on here, so when everything's fine, dashboards aren't super interesting. But when something like this happened, they can really help you get to the bottom of an issue. So we can see our KPIs fallen away from the baseline, so that's not good. We can see our errors by component has gone through the error threshold, and our latency in a single AZ has gone through the roof as well. So looking at this, you could probably be forgiven for thinking there's an AZ issue, it's something in the underlying infrastructure. But we've got clues because of the way we've visualized and sliced our data that tell us that may not be the case. So looking at the errors by component, there's only one component actually that seems to be throwing errors. And if it was an AZ issue, we'd probably expect to see more components. So by using annotations, we can correlate, or markers I think they can be called as well, we can correlate events from elsewhere in our platform with changes in our metrics. So in this case, we could toggle on our annotation that tracks deployment events, and conveniently there's one here that lines up with exactly when our metrics started deviating. We can imagine that's doing a rolling update, and that's why it's currently only impacting a single availability zone. And we could probably do ourselves a favor by initiating a rollback process before it starts to roll up to the other AZs and causes customer impact. So that's the kind of guidance we want to give people when we're talking about dashboarding and how to use observability. So whereas metrics give us the signal, we can use other features of our tooling to help us get a better idea of actually what's going
on. Maybe can I ask a question for the rollback? Do you use automation at all?
So automated rollbacks is something we're starting to look into, but it's not something we have now. So at the moment, it's kind of a workflow that will initiate that. We do have a release warranty process where we expect people to maintain a diligent posture after they've released it into production, which means so that issues like this, like that, are fairly obvious immediately, can be tackled at that point. But yeah, automated rollbacks is something that we're excited about looking at as we start to build out improve our developer experience.
I guess also with the rolling update, you reduce the blast radius as well, should there be a problem. So you identify it early enough.
Yeah, exactly. And you kind of take rolling update for granted. It's the default in things like EKS and Kubernetes, but you want it's kind of a really sensible way to deploy your applications. So to avoid that situation where you've gone too far, and because we're a global company, we also would probably start in obviously an environment that's not within its peak trading time, to give us any signals at that point. So we've also got some other tricks of our sleeve which we'll talk about in a little while as well.
Just to call out some of the things that, so in AWS we think of the kind of dashboards that you're talking about there as in terms of dimensionality. So I love the fact that you've called out it's latency per component. So you've got that deployment in there, and you can because you've got that intersection of those two dimensions, you're able to surface some really valuable business data on the back of that as well. So it stops your observability just being that sunk cost. You're getting to the point where you're presenting business data back to the business teams and being able to say, look, here's some real value in the insights that we're bringing, and we can turn this thing around a lot more quickly as well. So it's really nice to see the multiple dimensions being at play in there.
Yeah, and we call it different terms. So I call this platform level monitoring. We also have what we call the component level. So the engineers on call will be more interested in the workings of their components themselves, whereas other teams are interested in monitoring the platform. So the platform operations team that I mentioned, they've got that end-to-end view of what our customer journeys are looking like. And so by having those two different layers, you can get the high-level view of how impactful something is, and then you can drill down and start to actually look at what the metrics are telling you, then jump into your traces and your logs. And again, launch coordination, we give people a recommendation on how to structure dashboards. So this is the sort of generic dashboard structure we recommend. So each one of these boxes recommends like a row or a section in the dashboard. So at the top, high-level overview, so things like your KPIs or your key user journey, so measuring how those things are performing. Again, by using the tools I just showed you before, baselines, you can make sure you know what good looks like. You can also use things like single stat, so metrics that show a single number and change to any terrifying shades you need to when they're not within the expected range. And then working downwards, we'd have things like infrastructure metrics, so the runtime infrastructure of whatever we're looking at, and then application telemetry, so request responses, messages, and also things like traces and logs, so interesting ones that help us work in the right direction when we're trying to debug an issue. And then finally, dependencies. And if I show you an example of a component level dashboard here, for components, having that dependency view is really, really important, because in a situation where it may not be obvious what the cause of an issue is, you want to be able to look and see if your dependencies are the problem. You don't want to spend a lot of time looking at the wrong thing. So you can save a lot of time by having just a high-level view of how your dependencies are performing. And if you need to, you can move that investigation somewhere else.
And these dashboards, are they accessible across the company, like developers, infrastructure engineers, everybody?
Absolutely, yeah. So everyone in product and tech will have access to our tooling, for our observability tooling, because as Nisha mentioned earlier, sometimes during an issue you might need an extra set of hands to help sort of spread the load, to look at different things. And so by having the consistent structure and having the dashboarding available to everyone, you can really scale out those parallel investigations when you need to, and that can be really useful, especially if there's something that's getting towards being customer impacting. You want to have as many people as possible digging into things. So yeah, that's why you make it accessible.
I think and
really helps for. Sorry, go ahead, Nisha.
I was going to say the consistency does help in, like, you do not study the dashboard when you're trying to investigate. You know what it's talking, and everybody's talking the same language as well.
Yeah, it's kind of down to that muscle memory thing. Like production issues can be high pressure situations, so you really want to make things as easy as possible when the people responding. And so, and again, if I've got a team and I've recently had a component handed over to me or a feature, if I have to then completely relearn how to observe it as well and how to monitor it, that's an extra step I don't really need to want to take. So by adopting consistent structures, you just make the whole thing easier. So consistency and portability, really important to do this stuff at scale.
Yeah, I really like the fact that it is at the top level business process KPIs. It's highly, in some ways, abstracted from the technical point of view. It just talks about if something happens, like say somebody's not able to order, if they're ordering something airing out, if it happens or repeatedly, then only then you should be concerned. If there is one-off, then that is okay. I guess that's what it means, right? And then once you have that issue, then you can go dive deep in and find out the smallest component.
Yeah, exactly that. So I've just changed the slide here. So like our platform level monitoring is slightly, like I say, it's very high level, but it's the stuff that's really critical. So if we know if any of the core order journey KPIs aren't working well, that's going to mean our customers aren't having the best experience. So they're really important, and that's why we have the platform operations team there 24/7 to keep an eye on this stuff, obviously through alerting, but the dashboarding then helps to guide them into what sort of response we should be making. And things like aggregated infrastructure metrics. So if one component's running hot, it's maybe we just need to get in touch with one team. If lots of components are running hot, so like CPU's really warm, then we've probably got something of a wider issue. We probably need to sort of escalate to other teams to help us with that. Again, similarly, we've got, for our platform, you alluded to it earlier, Amaya, so people need to reach our platform to be able to order, and our restaurants need to be able to order to reach our platform and able to accept orders and give us updates. So it's really important we have that view of the outside coming into our platform. And then the shared dependencies, so the third parties, anywhere that we rely on to complete our order journey that isn't within the boundary of our organization. We want to know how they're performing too, because it could be that we have things like workarounds or switches we can press to mitigate third-party issues.
The other way around, like your dependencies, the third-party solutions that you're talking to, if they want to know some information from this environment, this platform, is that what external client metrics is? Like you exposing your information to them? No? No,
this is purely, so obviously we have, I guess it's like the north to south traffic, and then we've got the east to west traffic. So we want to make sure that the traffic coming into our platform looks healthy, because sometimes when you have these issues, it can be really difficult to work out where things are broken. And obviously we rely on the internet itself for people to get there. So what we want to make sure is that when we're investigating things, we're focusing in the right areas, really.
Got it. Okay.
And maybe a question from me. So suppose the platform team is monitoring the dashboard and they find an issue with one of your application or microservice, for example. So would you call that team in no matter what they are? And does the ownership lie with that team to troubleshoot and fix this?
Yeah, so the platform operations team will start the ball rolling. So they build out tooling that helps to automate a lot of this. So if they see something that we think is going to be impactful, they will use their automation. It will create an incident record, create a chat channel, create a conference, and then it will also escalate to the team. So they just need to choose which service is impacted, and that will escalate to the correct team. And then that team will get a notification. It will tell them exactly which conference they need to join. It will tell them a summary of the issue, and it will tell them which chat channel they need to join. And then the platform operations team will help them to triage the issue and help to do like any comms back to the business. But the onus is on the owning team to get to the bottom of the issue. And then we have other escalations routers you can help. If things are particularly tricky or we don't think we're getting traction, then we have other technical escalations paths who can be also brought in to help.
And I'm guessing, like, how often do you review the ownership where it's documented? Is it up to date? Because obviously things move quickly, people can move.
Yes, they do. So one of our, kind of at the center of all of our tooling, our applications and our observability is the fact that when we onboard applications, we capture a certain amount of data around that onboarding. And at the point of onboarding, we capture things like the tier of the feature of the application. So where does it sit in terms of our critical flow? And critically, we capture the team owner. So nothing gets to run in production without a team owner at JustEatTakeaway.com. It has to have a technical team owner, not an individual. It has to be a team. And from other metadata we can link that directly back to an on-call service, which we can get hold of. That data we also visualize in our developer platform, so it's easy to search who owns a specific application or service. And we also make it available via API for our tooling. So there's kind of this really, really strong source of truth that we use throughout our platforms. And we also use it to label and annotate our workloads. So again, and our metrics and traces. And again, it goes back to the consistency and portability. I don't have to know a lot about something to start digging into logs, metrics, and traces. And by using those consistent labels we capture, we were able to sort of speed up those investigations. We also use that data to control access to AWS resources and the pipeline. So in terms of keeping it up to date, it's really hard not to keep it up to date. So if you don't maintain the current state of ownership, you can't effectively work on your component or deploy it. So it kind of forces people to keep that up to date.
Got it. So, I mean, there's a lot of best practices here, right? So if I'm a new employee, I'm a developer or an infrastructure person joining, like how do I quickly get onboarded into this and not really deviate, right? So if I'm writing code, I want to make sure that I'm starting off correctly. Yeah. So we do publish the best practices. Like you say, there's quite a lot of it. So we leverage our tool. So we use application scaffolds to build applications, and then we use our CI/CD tooling as we're deploying it. So we get to
like build our best practices into our applications. We make it really easy to be compliant, and that's quite important. You don't want it to be easier to not comply with best practices. So from that perspective, so that's how we align the tech. So new people should be working on what's current. Now, as a new engineer at JustEatTakeaway.com, you will go to what was lovingly known as On-Call Bootcamp. And it's not as bad as it sounds. So it's a 2-day session. So the first day covers the expectations of what to do when you are on call. So if I get an alert from the platform operations team, I know exactly how soon I need to be there, depending on the criticality of the alert, and also I know what's expected of me. We also cover where to go. So this is kind of like your incident assembly point. So if you think you're looking at something that's impactful, or one of your alerts has told you there's something going on, you've come online, it looks like it could be impactful, we have a dedicated channel. So engineers can go there, speak to the platform operations team. So there's that human waiting for them, and then they can engage with the automation that I mentioned earlier on. Now, I didn't cover this at the time. One of the things we do, actually, we'll come back to in a second. So let me finish on the bootcamp in a minute. So the first day, we cover those two things. The second day, we have what's probably arguably the more exciting of the two. So we do an incident simulation. So this is where we take over a whole pre-production environment. So it has all of our apps and services deployed there, and you can actually get to a staging version of the site. And then we combine our two lots of our tools. So we have load test tooling and we have failure injection tooling. We combine those two things to make for some really sort of fun, full incident simulations where the attendees will be engineers who haven't been on call yet, and once they won't be able to, they've completed the bootcamp. They get to use all our observability tools. They get to use the incident response tools we have as well, and they get to do that under full guidance from people who've done it for a long time. And we measure how well we're doing there by engineer feedback. So like an exit score, a confidence score of our engineers, and that's how we improve this for future cohorts.
Yeah, this is quite structured, right? So if there's a new person coming in, they're definitely, or people who want to do this different role of supporting to be on call, I think they would be quite equipped when they go through this. They're not only learning about like the theoretical aspect of it, but also they're actually going through a simulated experience. That's really awesome, actually. Yeah, it's almost like game day. We call it game days, yeah, so similar.
I think those kind of simulations are fantastic. We run them internally within our own organization, certainly in support. It's a fairly frequent thing, and I think they surface a lot of things that you wouldn't necessarily think about. So you'll have somebody who is off sick. That's usually a key person dependency. You find out that their knowledge is essential to a particular outcome, or they could be on holiday, or worse still, they could get hit by a lottery ticket and they'll not be there after that. So you've got this a whole bunch of things that simulations can bring up, and then you've got capabilities like the fault injection service that can help surface through a little bit of entropy in your environment the things that your planned observability won't pull out, and being able to use that capability is, I think, invaluable in terms of getting the teams and the knowledge back into your observability. It's just great.
Yeah, absolutely. And I think, like you said, so in these on-call bootcamp incident simulations, the great thing is really no one's the expert in anything. So none of the attendees really have any expertise in the scenarios we're creating. And so what it really does kind of also help us validate is, can someone who doesn't really know about these applications pick up our observability tools and also look at the documentation, the operational documentation, and actually start to make steps towards resolving these things? And it's great. It's like really rewarding to see people work together, and and most of the time we run about 3 or 4 scenarios, and 9 times out of 10, like the engineers will get through all of them. And again, they don't have that background. And it's interesting you mentioned the fault injection service there. So we do some pre-production environments. We do some failure testing, and we've had really good results with using like an in-cluster agent to disrupt the application workloads. And then fault injection service makes it really easy to interact with the host infrastructure. So yeah, and you can get some really nice assurances normally around observability. So if you're moving to a different type of compute hosting or strategy or something like that, then having a way to inject these failures and actually understand just what happens is really, really, really useful practice.
It's finding the most difficult situations. There was a golfer in the 1960s who, rather unusually for the time, he was a professional. When he turned up to the courses, he would try and find the hardest shots. He would sit there and find the bunker and chip away until he got his hole in one on the green, that kind of stuff. And somebody watched him one day doing it, and he saw him get like 10 hole-in-ones in a row. And he comes up to him and says, "You're the luckiest golfer I've ever seen." And he says, "It's funny, the more I practice, the luckier I get." And that's very much what capabilities like Fizz does, is it provides you with that ability to, build your own luck. So it's nice to see that in action in JustEatTakeaway.com.
I think they're building the muscle memory, so it just comes by default when you actually hit by the instant, like click where to go.
Absolutely.
And Ian, you mentioned about the boot camp, and I was just wondering about some do you do any load testings as well to kind of see how your performance is happening at load?
Yeah, absolutely. So when we looked earlier on at my rather contrived dashboard scenario, so when we looked at that situation where a change had been deployed and we watched it rolling out, we're often not always, generally in technology, we're not always that lucky, right? So things don't always break as soon as you deploy them. They'll often wait until you want them to break when you really don't need them to. So normally when your platform's under load, so that's normally going to be your busy time. So a change you deploy earlier in the week might be fine until you start to hit those peaks, and then you start to have problems. So yeah, we do load testing. We load test our platform in production, and we do that daily. So we do that in different markets every day, and we obviously do it outside of peak hours. But what we do, we take an assessment of the highest peak load we expect for that market. And then for our load testing, we add 30%. So we validate our resiliency. So we follow the happy path through our platform, but we also validate our resiliency. So we want to know we've got that extra headroom. So if an event did happen anywhere on the platform, we know that we're not going to be left short of capacity to make sure that our customers still get that experience. And that's really important. Another really
just
nice
to be
thing,
clear, Ian, so here, this does not mean that your infrastructure is over provisioned for that capacity. You're essentially testing like auto scaling and all that because you want to be frugal. You're only provisioning what you need, but the environment scales for the load that you're testing that on. Yeah,
correct. Yeah, so
you want to make sure that message is out properly.
Yeah. Sorry. Yeah. So yeah, and this helps us with the kind of. We've had a sudden, so our inputs have changed. So one of the 5 causes, and we've hit some limit, and this helps us to avoid finding out the wrong time that we won't be able to scale correctly. So you could have like a quota set somewhere that you didn't know about, and yeah, you want to find out about that in the morning, not in the evening, in my experience.
Right.
And also, like I guess the other nice thing about load testing and from the observability side, we get the client view. So from the load test tooling, we get the view of clients. So we try and make the load test journey representative of our actual customer journey. And the client view gives us what the clients are seeing. And now if we're seeing issues from the client side that we're not seeing in our backends, we can make sure we update our observability to bridge those gaps. And again, it's a really nice process to do because it gives you that resiliency. You've got the reliability to fulfill your customer needs. You've got a little bit of headroom in case you need it, and also you get to validate that your observability is working correctly.
Yes, doing testing it every day is very impressive, I must say.
Yeah, we could. Sorry, Karen.
I was going to say, what next? Like, how are you? You're already so high up in the operational maturity. Like, what next?
So as I've been talking today, you're probably aware. So we have our metrics, logs, and traces, and we have a lot of documentation and expectations of people. So what we've been doing, so from an observability perspective, so whereas Gen AI is being used elsewhere in Just Eat Takeaway already, in our observability and reliability, we're building a data lake in AWS, and where we're trying to combine all these different elements of data, so around how we respond operationally and also our documentation, things like creating incident summaries for people. So if I join halfway through an incident, I haven't got an hour of messages to try and catch up on to figure out what's going on. So we're really sort of leaning into improving the experience of our engineers and our on-call teams by leveraging data that we've already got, but obviously you don't want to be trying to find it when you're under the pressure of a production issue.
Yeah. Which is really cool. So obviously the AI is definitely the key factor that is kind of helping us make sense out of all this tons and tons of data that is getting collected in this particular use case. Observability is probably the right use case for AI to be deployed in, because we all talk about finding the needle in the haystack and how we're going to reduce MTTR and MTTI and so on, mean time to troubleshoot and kind of resolve. I want to go to Paul and see, Paul, how are we from CloudWatch point of view, from AWS point of view? How are we addressing all of this?
Yeah, so it's quite timely that you're talking about these kind of things, Ian, in terms of the way we're thinking about it in AWS as well. So going back to Nisha's 5 causes, all of these things, when you're diagnosing them as a team, when you're deploying the teams to look at them, even when you're thinking about them, you know, in that parallelization way that Nisha was talking about earlier, it can take time, and the real value to a business is being able to get to that root cause really, really quickly. So trying to find out what one of those 5 causes or combination of them has been the thing that has resulted in this, and the way we're viewing that in CloudWatch is through agents, deploying agents that can help you get there faster, that can parallelize the application portion, the infrastructure portion, the network, that kind of thing. And as we go through the evolution of these incidents, you've got that opportunity to start to dive really deeply, but really, really quickly, and get the information out that you need as soon as possible. I'm just going to walk through a little scenario here. We've got a little bot service that has an unhealthy state in it. What you can do with the investigations in here is you can give it your investigation a name, and then you can just kick off that investigation to try and find out what the issue is that's created that unhealthy state. And that's going to pull together a whole bunch of different data sets, and in there's all sorts of information that's being pulled in. You can look into there and say, well, I want to pull in this trace or this log file or this piece of information into the investigation. I can go into more detail if I want to and say, well, is there more in here that is going to help get the resolution that we need very, very quickly, and is all of this data the pertinent data that's going to help me get to the result that we need.
I really like the human in the loop process there. Like, it allows you to sort of like accept. That means you're telling it that, yeah, what it found was actually useful and it made sense for that.
Absolutely. And the nice thing is it's the information that is then presented back to the human. So you can say, right, well, this investigation makes sense to me. I accept this investigation, but I really want to understand what's going on in the background on this. So I can see all of the information. I can see which logs are pointing here, which services are associated with, but why has this happened in the first place? And then you can go in and take a look at the hypothesis behind it. And that hypothesis can give us an awful lot of information on the back of it. It's broken down into a whole bunch of capabilities in here. There is a confidence score, then there is a breakdown of the actual event, and then possible next steps in terms of how you think about those. You can also dive into the reasoning behind it and get into more of the detail. But one of the nice things about it is, in this set of circumstances, it's gone straight in and said, we've identified one of your 5 causes. Somebody in there has changed an IAM role. It's no longer allowing access to the capability that we need it to get access to. And the nice thing after that is that you've got those next steps that you can say, well, how do I go about remediating this? These are the things that you can do. The thing I like the most is there's this kind of little finger waving from the AI in the mix of it all, saying, Paul, come on, you can do better. Put proper change management procedures in place, because you shouldn't be making this kind of mistake in the first place. And I think that kind of stuff is quite nice to see in there as well.
Yeah, every incident is a lesson learned. What not, so it doesn't reoccur. Yeah.
I really enjoy that.
Sorry, Guardian.
I say no. I was just saying I enjoy that you can get in the CloudWatch agent to have the awkward conversation with someone about the change control process on your behalf.
It's never personal. It's just an AI. So
I'd have to apologize about 6 times before I said that to someone. So yeah, it's great.
All right, this is great, Paul. Where can one learn more?
So we've got a whole bunch of information that's out there. There's some QR codes there that's going to be very useful. I really like each one of these. The post about the instrumentation for distributed systems, really insightful. The One Observability Workshop is just a great way of getting hands-on with the different capabilities. It's really easy to deploy, and it's really easy to roll back once you finish with it. Looking through the intelligent operations, that's a lot of the stuff that we just looked at there in terms of the capabilities. Plus, there is additional stuff that was announced last week in New York Summit, just on the 23rd. And there's a blog post there about the generative AI observability that's baked into CloudWatch now. So there's a lot of information out there, and plus you can reach out to us through the usual channels as well.
Right. Yeah. So obviously we're always here to answer questions, to engage with you. If you want like hands-on experience, there are multiple avenues for you to do that. Yeah, I just want to highlight on the last portion, the generative AI observability, Paul, that you mentioned. That is observability for Gen AI workloads, right? Yes. So this is specifically Bedrock Agent Core observability. I mean, not only that observability is not only for those that are running on Bedrock, but also that's running on any environment, EKS, ECS, or anywhere else.
Yeah.
It's just first class native observability experience for agents, because we're increasingly seeing customers kind of interested in replacing microservices that have custom logic with things that maybe it's making an API call to something and then just processing that information. Why not just a model do it? Because it also can do more than what just the custom code does. Because the more lines of code you write, there's the chances of increased number of issues and bugs. But we are in an exciting time, and there's a lot of transformational things happening, and it's always exciting to learn these things and implement. All right, thank you. Is there anything else that we need to talk about, or we have covered all the best practices that we want to talk about? You good?
I just want to maybe one final note, like don't be scared of incidences. It's always a learning curve. Just embrace them and just see how we can get better. And it's like a journey thing. That's a lot of I always tell my customers to like, don't look down upon them. It's just helping you get better.
Right, just be prepared. That's what you're saying.
Yeah, be prepared. Tech will fail. The failures will happen. Just be prepared. Yeah, and with observability, you just have you can mitigate the issues quicker.
Yeah, that's my biggest takeaway, amongst other things, from Ian today. That how prepared they are, how structured they are. I think that is really critical. I've seen time and again the organizations that are structured, and they expect what they want to do when an incident happens, and then they work backwards and then plan accordingly. Other ones that are quite successful, other ones that are able to resolve issues quickly and move on to the next thing, and build things faster and so on, which is really amazing. All right, we are at the end of the show. First of all, or once again, thank you for all three of you, Nisha, Ian, and Paul. You are on the other side of the Atlantic. For me, it's just 3 p.m. but for you, it's 8 p.m. or something like that. So thank you. It's your dinner time, or maybe past your dinner time. Thank you so much for taking your time away from your evening and sharing with us. This has been such a learning experience. And again, Ian, thank you so much for being an AWS customer and being willing to come out and share your experiences with us.
No, I mean, it's been great. Thank you for the opportunity, Mary. It's been great experience. Thank you.
All right. Thanks, everybody. Thanks for watching. And we'll see you in 2 weeks' time with another exciting topic. See you later.